Our method is non-homogeneous linear recurrence relations if the Gn equals to, listen clearly, Gn equals to a linear equation means C0 plus C1 into n. In this case, particular solution An of P equals to, just assume D0 plus D1 into n. This is our model. Okay, now we have to discuss this model problems. Yeah. Now I will already explain this one. I will explain this model by using an example. Okay, see the example. Suppose solve the recurrence relation. Solve the recurrence relation Solve the recurrence relation an minus 7 into an minus 1, an minus 7 into an minus 1 plus 10 into an minus 2, that equals to 6 plus 8 into n. Okay, this is the recurrence relation. Initial conditions also given. Here a0 equals to 1, a1 equals to 2, a1 equals to 2. These are called the initial conditions. Keep this one, a0 equals to 1 and a0 equals to 1 and a1 equals to 2. These are called the initial conditions. Yeah, this is a given problem. Now require the solution. In this solution, the step 1, what I told to you, step 1, write all the a terms in the left side, keep the constants and n terms in the right side. Already given problem. See, in the given equation, all a terms in the left side. Therefore, it is right. An minus 7 into an minus 1 plus 10 into an minus 2. So first a term, second a term, third a term, all the a terms in the left side. Very good. And equals to the right side part is the 6 constant plus 8n. This is n term. Constant and n terms in the right side. So don't write any a term or an term in the right side. Okay, this right side part is called the Gn term. This is the very, very important. This is the Gn term. The Gn term in the form of linear equation. Linear equation means, if you observe here, you can easily understand this is some C0 plus C1 into n. This is called the linear. Linear. Okay, so if it is in the form, then what is the particular solution? I clearly told you the particular solution an of p equals to d0 plus d1 into n. This is the particular solution in this case. Okay, that is now we have to discuss. Okay, before going to that one, come to the step 2. Okay, what is the step 2? General solution. I will denote this one by the equation 1. Write the general solution. All of you look at the screen properly. It is a very, very important. The step 2 is the general solution. General solution of non-homogeneous linear recurrence relation. That means equation 1. So non-homogeneous linear recurrence relation. If you take non-homogeneous recurrence relation, it contains the sum of the two solutions. What is that? An of h is the one solution and an of p is the one solution. Here an of h is called solution of homogeneous linear recurrence relation. Homogeneous linear recurrence relation means here Gn equals to 0. Gn 0. That is, this is the particular solution. This is called the particular solution. Now we have to find these two solutions. One is solution of non-homogeneous recurrence relation. Another solution is particular solution. These two we have to find. Okay, first we can find the solution of homogeneous recurrence relation. Homogeneous means I clearly told to you Gn equals to 0, then it is called the homogeneous. Therefore, here Gn, G of n equals to 0. This is called the homogeneous. Therefore, I will come to the step 3. Step 3, if we require the first solution is homogeneous. Homogeneous means Gn equals to 0 in the equation 1. In equation 1. In the equation 1, Gn 0 means right side part is 0. Then the remaining part is An minus 7 into An minus 1 plus 10 into An minus 2 equals to 0. 0 means here I am taking Gn equals to 0. This is called the equation 2. This equation 2 is also called homogeneous linear recurrence relation. So now we require the step 4. What is the step 4? Characteristic equation. Characteristic equation. What is the characteristic equation? Characteristic equation means substitute An by r power n minus 7 into An minus 1 by r power n minus 1 plus 10 into An minus 2 by r power n minus 2. This is. Therefore, this equals to 0. Here you can take the least power. What is the least power? R power n minus 2 is the least exponent of r. So r power n minus 2 you can take common. If you take r power n minus 2 common, r power n minus 2 is common. Then the remaining part, what is the remaining? If you take r power n minus 2 common, then you will get r square minus 7r plus 10 equals to 0. Very good. R square minus 7r plus 10 that equals to 0. Finally, you can write r square minus 7r plus 10 equals to 0. Now we can write in the factorizations. Find the roots. Root means you can write r square minus, this can be written as 5r minus 2r plus 10 equals to 0. Just take r common here. If you take r common, then you can write r minus 5. If you take minus 2 common, you can write r minus 5. Already you know how to take these factors. This can be take r power r minus 5 is common. Then you can take r minus 2 equals to 0. Finally, you can take r equals to 2 comma 5. These are called the roots. Okay. The step 5 is roots. What are the roots? The roots r1 equals to 2 and r2 equals to 5. These are the two distant roots. Distant roots. If you find the distant roots, what is the general solution I told to you? If you find the distant roots, the step 6 is general solution. General solution of 2. 2 means general solution of homogeneous linear recurrence relation. In the homogeneous recurrence relation, if the roots are distant, I clearly told to you C1 R1 power n plus C2 R2 power n. This is the formula. In this formula, an of h equals to C1 R1 means already you know 2 power n plus C2 into R2. R2 means 5 power n. This is the our required general solution of homogeneous recurrence relation. This is the equation. This is the equation 4. This is the equation 4. Okay, keep this point. This is the equation. This characteristic equation is the equation sum 3. Find the characteristic equation. This is called the characteristic equation. Okay, find the characteristic equation, then find the roots. After finding the roots are distant, then the formula is C1 R1 power n plus C2 R2 power n. R1 means 2 power n, R2 means 5 power n. This is the equation 4. One part is completed. Now come to the next step, particular solution. Okay, step 7 is particular solution. Particular solution of non-homogeneous linear recurrence relation. That means equation 1. So particular solution, what is our model? See, C0 plus C1n. Then the particular solution an of p equals to D0 plus D1n. This is the particular solution. Therefore, here our required particular solution is an of p equals to D0 plus d1 into n. This is the particular solution. Suppose this is this particular solution. Suppose this is I am denoting by 5. This equation 5 we have to substitute in the equation 1. Substitute equation 5. Equation 5 means an of p equals to d naught plus d1 into d1 into n in given equation 1. In given equation 1. Okay, we have to substitute this equation 5 in equation 1. First write the equation 1. What is the equation 1? From 1, first write the equation 1. What is the given equation? An minus 7 into an minus 1 plus 10 into an minus 2 equals to 7. Sorry, an minus 7 an minus 1 plus 10 an minus 2 equals to 6 plus 8 into n. This is the equation 1. In this equation 1, what can we substitute? At the place of an, we have to substitute d naught plus d1 into n. This is an. But what is an minus 1? an minus 1. If you require an minus 1, substitute at the place of n, we have to substitute n minus 1. Suppose if you require an minus 2, substitute at the n, we can substitute n minus 2. These are we required. Okay, an already you know. If you require an minus 1, at the place of n, substitute n minus 1. You can see clearly, you can observe. Yes, at this place of n, you can substitute n minus 1. Similarly, here n minus 2. At the place of n, substitute n minus 2. So similarly, we required an minus 1, an minus 2. Substitute that value. An means, I am substituting clearly, check it. An means d naught plus d1 into n. This is a naught value minus 7 into an minus 1. Already you know an minus 1. d naught plus d1 into n minus 1. Then plus 10 into d2. d2 means d naught plus d1 into n minus 2. Okay, these are that equals to 6 plus 8n. This is, I substituted all the three values. Okay, now simplify this one. D naught plus d1 into n. Multiply with, after that we can multiply 7 into d naught plus d1 into n minus d1 plus 10 into d naught plus d1 into n minus 2d1, that equals to 6 plus, that equals to 6 plus 8n. 6 plus 8n. Now simplify this one. D naught plus d1 into n minus 7 d naught minus 7 d1n minus into minus plus, minus into minus plus 7 d1 plus 10 d naught plus 10 d1 into n, 10 to the 20 d1 plus, sorry, equals to 6 plus 8n. This is equality. Yes, this is. Now simplify this one. D naught, how many d naughts are here? Check it. D naught minus 7 d naught. Then here also one of the d naught is here. What happened 7? 11 minus 7. What is this value? 4 d naught. Am I right? Yes. 4 d naught. Yes, 4 d naught. Next, count the d1s. How many d1s are here? d1 n, here 7 d1 n and 10 d1 n. Okay, before that, clearly listen, my dear students. First, I am taking the only d1. Here only there is a plus 7 d1. 7 d1. Is there any other d1? 7 d1. 7 minus 20. Clearly listen, all of you. It is a very, very important to you. You have to observe 7 d1 and minus 20 d1. Finally, minus 13 d1. Am I right?
Yes.
Yes. Therefore, this can be written as clearly listen, my dear students. It is a very, very important one. First, you can take minus 13 d1. 13 d1. Next, dn minus dn and minus 7 dn. That means minus 6 dn minus 6 dn plus 10 d1n. That equals to 6 dn. Am I right? Once again, I am telling you
Plus
d1n and minus 7 d1n. That means minus 6 d1n. And then come to here, 10 d1n means minus 6 plus 10, 6 d1n. Am I right?
4 T1N, sir.
Sorry, 4 d1n. Am I right? Yeah. Finally, the remaining all values counted, that equals to 6 plus 8n. Am I right? Yeah.
Yes, sir.
Now check it. This is the constant term. In this term, there is no n term, but this is n term. Now count it. Here you have to now compare. If you compare, this is the constant term is equals to 6. This is equals to n term. You have to observe clearly. Here, this is the 4d0 minus 13d1. This is the constant term. This constant term is equals to 6 and 4d1 into n. d1 into n means this is the n term. Here 6n. 6n means this term is also contain n. Therefore, compare the two constant terms. Constant term means 4d0 minus 13d1, which is equals to 6, and n terms. Compare the n term. Here the coefficient of n is 4d1. In the right side, the coefficient of n is 8. Therefore, if you simplify this one, you will get d1 equals to 8 by 4. Finally, d1 equals to 2. Therefore, this is d1 equals to 2. Yes, this 2 1 we can substitute here 4d0 minus 4d0 minus 13d1 equals to 6. In this equation, already you know 4 d0 minus 13 d1 means 2 equals to 6. If you simplify this one, 4 d0 equals minus 13 to the 26 equals to 6. Then this can be written as 4 d0 equals to 26 plus 6, that equals to 32. Therefore, finally, d0 equals to 32 by 4, that equals to d0 equals to 8. Okay, have you observed how to find this d0? So finally here I am writing d1 equals to 2, d1 equals to 2, and d0 equals to 8. Okay, these two values we find here. Okay, finally we found these two values. These two values you can substitute in the particular solution. Okay, see the particular solution. You can see what the particular solution, an of p equals to d0 plus dn. Okay, equation 5. Equation 5, particular solution an of p equals to d0 plus d1 into n. Therefore, from the equation 5, just clearly observe, it is very easy. From 5, an of p equals to d0 plus d1 into n. Therefore, an of p, d0 means 8 plus d1 is 2n. This is the particular solution. This particular solution is denoted by some equation 6. This is particular solution. So therefore, general solution of equation 1 is 2. Equation 2, what is equation 2? Equation 2 means solution. An equals to an of h plus an of p. an of h already you calculated. An of h already you calculated. What is an of h? C1 2 power n, C1 2 power n plus C2 5 power n. This is the particular solution. Sorry, general solution of homogeneous part. Particular solution is equation 6, 8 plus 2n. This is the solution, general solution. This is denoted by 7. The final step is equation 10 is initial conditions. Initial conditions. What are the initial conditions? What are the initial conditions given? Here, the initial condition, there are two initial conditions, an naught equals to 1 and a1 equals to 2. These two initial conditions are given. From 7, what is the equation 7? An equals to, equation 7, an equals to C1 2 power n plus C2 5 power n plus 8 plus 2n. This is the equation 7. But in this equation 7, I want substitute 0, n equals to 0. Why we have to substitute n equals to 0? A naught already they given 1. Therefore, substitute n equals to 0. Then finally, you will get a naught. C1 2 power 0 plus C2 5 power 0 plus 8 plus 2 into 0. Finally, what happened? If you simplify this one, C1 2 power 0 means 1 plus C2 5 power 0 means 1 plus 8. This is A naught. But already you know the A naught value. A naught value already they given 1. 1 equals to C1 plus C2 plus 8. This 8 comes to this side. 1 minus 8 equals to C1 plus C2. Finally, we can get C1 plus C2 equals to minus 7. Suppose this is some equation A. Now substitute n equals to 1. Why we have to substitute n equals to 1? Already a1 value already given. a1 equals to 2. Therefore, you can substitute n equals to 2 here. So a1 equals to c1 2 power 1 plus c2 5 power 1 plus 8 plus 2 into 1. That is substitute n equals to 1. If you substitute 1 equals to 1, then you will get a1 equals to c1 2 power n plus c2 to 5 power n plus 8 plus 8 plus the 6 plus, sorry, 6 plus 8n, 6 plus 8n, n means 1. Okay, just my dear students, at the place of n, what I told to you, substitute 1 only. C1 2 power n plus C2 5 power n plus 6 plus 8. Therefore, then finally a1 value already they given, a1 equals to 2, 2 equals to C1 2 plus C2 5 plus 8 plus 6 plus 8 is 14. Therefore, this 14 comes to this side, 2 minus 14 equals to 2C1 plus 5C2. If you simplify this one, finally you will get 2C1 plus 5C2 that equals to minus 12. This is some B. Equation A already you got here. This is equation A. Now I want to multiply equation A by 2. If you multiply with 2, the equation, now I want to multiply equation A into 2. That means equation A, see, all of you look at equation A. 2C1 plus 2C2 equals to 7 2s are 14. Therefore, if you multiply the equation 2 by 2, then you will get 2C1 plus 2C2 minus 2 7s are 14 minus 14. And you can take the equation B. What is the equation B? 2C1 plus 5C2 that equals to minus 12. Minus 12. So if you subtract one equation from the other equation, the symbols will be changed. So these two equations, these two first two terms will be cancelled. Then finally you will get, this is minus 3C2. 2 minus 5, 3. 2 minus 5 minus 3 C2 that equals to minus 14 plus 12. Minus 14 plus 12 is minus 2. Therefore, C2 equals to 2 by 3. Okay. The C2 value is, is there any mistake? All of you look at here. Student, is there any mistake in this solution?
No, sir.
Is there any mistake? Yes or no? Yes or no? Are you hear me? Students, are you hear me properly?
Yes, sir.
Is there any mistake? I am asking, but no one responding. From equation A, what is equation A? C1 plus C2 equals to -7. Okay, C1 plus C2 equals to -7. Okay, in this C1 value already we don't know, but C2 already you know. What is the C2? 2 by 3 equals to -7. Am I right? Am I right? Students, are you hearing me? Are you hearing me?
Yes, sir.
Yes. Check it. Here I did the mistake. That's why I'm asking, but no one responding.
Sir,
An of p equals to 8 plus 2n.
8
Am I right?
plus
Yes.
you
8
written it.
plus 2n. The 8 plus 2n you are not telling properly. 8 plus 2n means here there is a mistake. I found it. 8 plus 6. 8. Sorry. See once again I will show you. 8 plus 2n. Okay. 8 plus 2n. But here I did a mistake, but no one responding. This is what is this? 8 plus 2n. Am I right? Am I right? Therefore, this value is 10. Okay. Then this 10 comes to this side. It should be 2 minus 10. 2 minus 10 means -8. Are you okay now? Hello? Students, are you okay?
Yes, sir.
Yes. 8 twos are? What is the 8 twos are? 16. Are you okay? Then A multiplied by 2, and then we can take B and subtract both, then you can find C2 equals to 2. So substitute that C2 value, that C2 equals to 2 in the equation A, then you will get C1 plus C2 means 2, that equals to 7, therefore C1 equals to -9. Substitute the C1 equals to -9, C2 equals to 2 in the equation 7. What is equation 7? Equation 7 is an equals to C1 2 power n plus C2 5 power n plus 8 plus 2n. 8 plus 2n. Therefore, an equals to C1. C1 already you find -9 2 power n plus C2 already you find. C2 already you find, that is 2 into 5 power n plus 8 plus 2n. This is our required general solution. General solution of given recurrence relation 1. This is, my dear students, that's a third model. These three models are very, very important. I will share this PDF and also the recorded video. You can see, watch it. Any doubt, you can watch it. Even you have a doubt, then you can call to me. Are you okay?